Hey guys, we made it. It's lesson 10, which is the last lesson of this unit. We're going to be looking at composition of two functions. Now, the reason we do this is because we've been talking about inverses. We were able to graph them in 1.8 and we were able to write them in 1.9. Now we're going to be using composition to determine if given two functions, if they are inverses of each other. Let's go ahead and get started. Our learning target is I can use composition of two functions to determine if the functions are inverses. Our success criteria, we need to be able to identify function 1, function 2, and then substitute function 2 into function 1, simplify the equation. And then we're going to repeat the process using the other function. We'll plug in function 1 into function 2. And then we determine if the inverses are actually if they're actually inverses of each other. And we know that if they both simplify to y is equal to x. All right, so let's go ahead and review evaluating. And when we have f of x is equal to 2x plus minus 1, if we're evaluating, that means that whatever is in the parentheses where x is, that's what we're going to plug into the rest of the equation. So instead of x, we will plug in 4. So 2 times 4 is 8. 8 minus 1 is 7. So f of 4 is equal to 7. We plug in 4 and we get an output of 7. Let's go ahead and evaluate for f of negative 3. So we start with f of x, and then I'm going to identify where that x value is, because where that x value is where I'm going to plug in that negative 3. We've got 2/3, plug in that negative 3, and when we multiply a fraction times a whole number, put it over 1. 2 times negative 3 is negative 6, divided by 3. That gives us negative 2 plus 4. So f of negative 3 is equal to positive 2. When we input negative 3, our output is positive 2. All right, so what is composition of functions? Composition is when we get one function and we put it on the other one. So example is like this pizza. If we have f, the function of f stated first, that means we're going to have this whole pizza, and then we're going to place g of x on the pizza or on that function. So it's like a pizza, and then you put the pineapples on top. If it's the other way around, say we do have g of x and we get the pineapple, and as silly as this is, we would put the pizza on top, or put the pizza on top of the pineapple. So we're basically looking at what is our main function. Let's look at this example. We're given two functions, f of x and g of x, and it wants us to find f of g of x. So we're first going to do f of g of x. Notice how f, the function of f, is stated first. So the first thing we want to do is rewrite that first function, 2x minus 3. Then we want to put parentheses around where that x value is, because that x value is going to now become g of x. So wherever that x value is, we will put g of x, which is 7. Now is simplify. 2 times 7x is 14x minus 3. Because we can't simplify it any further, then f of g of x is equal to 14x minus 3. Let's go ahead and try the next one. Now we're going to get g of x, and we're going to plug in f of x. So again, we start with writing our main function, which is g of x, which is 7x. I'm going to put parentheses around the x value, because in that spot, I will be plugging in f of x, which is 2x minus 3. And now we simplify. 7 times 2x is 14x. 7 times negative 3 is negative 21. We can't simplify any further, so g of f of x is equal to 14x minus 21. Go ahead and go on to the next example. we're given these two functions. We need to find g of f of x, f of g of x and g of f of x. Sorry. Let's start with f of g of x. So let's write down our first function, and then we put parentheses around where we're going to substitute for g of x. Let's go ahead and rewrite it. We've got x plus 1, and then we continue with plus 5. Now we just simplify. We get x plus 1 plus 5, and we get x plus 6. So f of g of x is equal to x plus 6. Now let's try the next one. We've got g of f of x. So we start with our main function, g of x, and g of x is x plus 1. Let's put parentheses around that x value. And instead of that x value, we're plugging in f of x, which is x plus 5. Because nothing's happening with that parentheses, we can just drop it. So we get x plus 5 plus 1, which is x plus 6. So g of f of x is equal to, okay, let's go on to the next example. F of g of x, f is on the outside, that's going to be our main function, so let's rewrite that one. The parentheses around the x value only, and instead of x, we will plug in g of x, which is 5x. Notice how that squared is in parentheses, outside of the parentheses. And when we use PEMDAS, we need to do exponents first. So over here, we've got 5x squared means we're going to square the 5, and we're squaring the x. 5 squared is 25, and we get 25x squared. We're going to replace that in here, and now we just simplify. This is 50x squared plus 5. So f of g of x is equal to 50x squared plus 5. Let's go ahead and look at the next one. We're going to do g of f of x. So now our main function is g of x. We've got 5 times x. Identify where we're going to substitute, wherever the x is. So we've got 5, and then instead of x, we will plug in f of x, and we just simplify. 5 times 2x squared is 10x squared. 5 times 5 is 5. We can simplify further. So g of f of x is 10x squared plus 5. All right, so now that we know how to compose